Okay, so in the last video we finished our first part, but now we're going to take a look at the second part. So if we have a quick look at the Dropbox folder, if you have a look down at the bottom of this YouTube video, you'll see a link that is going to take you to the Dropbox and you'll be able to download these files here. So again, if you're using NX2212 or further, you can use the .prt file, which is always best. And if you're using an older version of NX, then look at this step file here. We also get a drawing with it. So let's open it up and take a look. Well, this looks very similar to the first part, doesn't it? And that's because a big part of programming is doing very similar work. So if you work in Formula One or other things, it's constant iteration environment. So you program the first thing and then design come back and they've changed a few things here and there. It's very slightly different. So we're going to go through the process of that now. So this part here, it looks almost identical. We can see we've actually got some engraving on the back of it here. And also things might be slightly different, but I'm going to leave that to you to decide. So what I would advise is that you open up the drawing. So let's have a look. And then I would open up the second drawing, the part 2 drawing and the part 1 drawing, and just have a look if there's any slight differences. There'll be a few small changes in there to catch you out, but what I want you to do is I want you to take some time now, and I want you to go through the steps that we did in the first part. You can obviously go back to the previous videos if you get stuck, but I want you to try and program this part by yourself now. So I'm going to go ahead and I'm going to give you a little bit of time. So pause the video and come back when you've got at least your operation 1 done or your op 2. It doesn't really matter because I'm going to show you how I would do it anyway. But yeah, take some time now and I want you to go away and program this by yourself. Okay, pause the video now. Okay, so now I'm assuming you have programmed this part complete. So this was a nice little first challenge, I want to say. It's not really a challenge because you're just getting into repeatability. After this part, we will have a challenge that you're going to go away and program entirely yourself. It's going to be different, but we'll go through that in a future video. So let's start going through how I would program this part now. So the first thing I'm going to do is I'm going to open up the first part. So let's go and open up the first part. So this is the first part, and I actually want the cam session, not just the part itself. But let's open up the cam session. Okay, so it's just saying it's move things around so it can't find the part. It's the actual part. The link body's fine and the program's fine, so it's nothing to worry about. So what I'm going to do here is I'm going to just hide that screen. Put link body on. Okay, so this is a little trick. So you obviously you can't expect me to go and program this part all again, and surely I'm never going to do that. So I'm going to show you a quick trick. So it was a little bit of a test, but it was also a bit of fun from my behalf to trick you into having to program this whole part again. So I'm going to show you a really neat way, and it's called replace component. And this is going to save you a lot of time when it comes to repeat work like this, where it's slightly different. So what I'm going to do is I'm going to go and find the component in the tree. So this is my main part, or as we call it, our design master. So in here, I'm going to right click, and you'll see you have this option here called replace component. I'm going to replace the component. And now you can see it's got my component selected in the tree, and it's asking me what do I want to replace it with. So I'm going to go ahead and I'm going to go and find my second part. So your structure will be slightly different to mine. Here's my second part. Okay. So it's got it. And I'm going to hit OK. That's going to go away and it's going to go and replace the part for me. So let's have a look what we've got in the tree now. So now we have our new part, our second part. And because our link body is all associative, you'll see if we double click the link body, we do have associative ticked on. So it's already updated our link body for us, which is amazing. Obviously, this result in stock we don't need that for this file. But at this point, now I've just replaced a component. I'm going to go ahead and I'm going to save this. I'm going to save as it is my part 2 op10. So part 2 op10. I think that's the same naming format as we did before. Just keep it same. Oh no, I did a dash. Just put a dash in there then. This isn't important, it's just keep it all very similar. Okay, so now I'm working on my my op10 part 2 file. So this result in stock, I can delete this now because we don't actually need that result in stock there. And also you'll see we've got our link body, and yeah, we've got the link body which is already updated. It's green. Our cam workpiece probably would have updated with it as well, so we can just double check that. It's all the same size, so there'll be no differences there. Okay. So now our tree is looking nice and neat again. We have our new part in here, and now I'm ready to go to the cam session already. That quick. So a few things are going to change. So if you looked at the drawing, one thing you would have noticed would be, hopefully you noticed that these whole positions have changed. So the positions of these holes have slightly changed. The diameter of the holes have changed from 4.2 to 4.5. And we also have a slightly bigger chamfer as well. We have a 1mm chamfer now rather than a 0.5. So, go back to the part. So what do we need to do now? Well, we need to rename the program to a proper name. It needs to be part 2. Okay. Let's double check our geometry. Let's see if everything's updated. So our datum, that is still the same. It's in the middle of the block. That's not moved. Our workpiece, that's still the same. And you see it's picked up the new workpiece. This is because everything's linked. This is the beauty of working in this way, especially with NX. We already have our stock all set up. The tools, obviously that's all the same. And the method groups, that's also the same. So now we can just go in and generate. We can start generating things because we know that the adaptive milling is not going to change. The top facing, that's not changed. And we know these pockets haven't changed either. So we can actually go ahead and just generate this whole folder. Just like that. We've completely roughed out this part. As quick as that. Okay, now let's look at the finishing. So we know these pockets haven't changed. This outside profile hasn't changed. The top face hasn't changed. Neither has these walls. Neither has those chamfers. Neither has the outside profile. So now we can go ahead and generate this whole folder too. Have a quick look, make sure we're happy with what it's done. Now obviously we're going to verify this afterwards to make sure we are safe, but this all looks really good to me. Okay, now onto the holes and drilling. So you can see here the hole positions are completely out here because they have changed. And we've got a 4mm drill, which is fine because it's undersized for the 0.5 anyway. So now let's go and have a look at this here. So with this being feature-based machining, you can see already it's re-picked up these surfaces for us. It's re-picked these holes. This is so important, and it's amazing when designers work in NX and it gets transformed over to CAM, because these little bonuses that happen here, because when a designer changes features, it's very rare that he'll just delete these holes out and put them in again. It's more, what happened more often than not is he just changes the hole position. So the actual holes are the same, it's just they're in different places now. So we should be able to go ahead and just regenerate this drilling. You can see now we are drilling down the middle. This chamfer won't change either because it's linked to the feature-based machining too. So we can generate that. So this one's changed slightly. So you can see that because now we need to go slightly deeper. So, I mean, it's close, but it won't be. Yeah, we need to regenerate this and we need to go slightly deeper. So let's do that. So we go into the planar mill. We need to lower this floor because we currently went -1. and that was assuming that we had a 0.5 mil chamfer, but now we are a bit less than, we're a bit more than that. We're at 1 mil chamfer, so I'm going to go 1.5 just to go past the edge and regenerate this toolpath. Just like that. That's that nicely updated for us. And now here. So this is the biggest change of this program because we're at 4.5 now. And in hindsight, as the diameter wasn't really important, it was the positions, it probably would have been nicer to do a helical cycle in here with an end mill. So we can actually go and have a look. We do have an end mill here, a finishing end mill, which is a 4 mil by radius 1. So that could suit this really nicely. And we could just helical mill down these holes. That will mean that you do get a good position, and also it doesn't matter on the diameter. So now we can go ahead and change this cycle out. So I'm going to add a helical mill cycle. So let's go into, I'm going to select this toolpath here, because when I insert a toolpath, it's going to drop underneath this one. I'm going to insert, operation. We want to be under hole making. And you'll see here we have this hole milling cycle. So we can put it under there, which is fine because it's inheriting from the toolpath. The tool, we're going to use that 4 by R1. And we want to put it under the 4.2 holes group so it picks up the hole for us without us having to select them. And we're going to put this under the mill finish group. Okay, so now this is going to be a new toolpath for us. So in the main, you can see we've already got the tool selected because we've just done that. And in here, if we just hit this eye, we can see it's got those holes for us too. And if you open up this dialog, you'll see you'll be presented with quite a few different options where we can change this toolpath around a little bit, but we've actually got it spot on for what we need here. We don't need to change anything. You can see how it's all grayed out, and that's because it's been linked from the feature. If we untick this and say user defined, then we can start changing the diameter to 8 mil. You can do various different things, and you can see it's actually got the hole through the middle because it knows that's what was drilled. But for us, we need to keep this all associative. It's not good practice to be changing things in this dialog here. So you can see it's got the start diameter of 4. That's because it knows we have used a 4 mil drill prior to this. It's really clever, feature-based machining. You'll see here you've got a few different options in here telling you different information. So we've got start diameters, depth limits, and tip angles. Tip angle is irrelevant because it's a through hole. Okay, so we can see we've got the right geometry selected. Now cut patterns. So you can see here you've got a few different options. So a spiral will drop straight down to the bottom of the hole and spiral outwards, which we don't want to do really, because it's a 4 mil hole and we're using a 4 mil tool. Circular will just drop down to the middle and do one pass as in a circular move and move back to the middle. And helical is the main one, which we're looking for because that's going to start at the top of the hole and helical all the way down to the bottom. Helical and spiral is a pretty interesting one as well. You can helical down to the bottom of the hole. So for example, if this was a 10 mil hole and using a 4 mil tool, we could helical down, creating a 7 mil diameter, let's say, and we helical down all the way to the bottom, and then when it hits the bottom, it starts to spiral outwards. But we want the helical pattern. We don't want to leave any side stock because we want to finish this wall. The geometry has already been selected from the holes. Cutter comp, we don't really need cutter comp because as we saw in the drawing that the actual diameter is not important. Feeds and speeds, so for a 4 mil alley, I would be about 8,000 for a hole, and this is pretty small because we're actually creating a 4.5 mil hole and using a 4 mil tool, which isn't ideal. If you could get away with it, I'd rather use like a 3 in a 4.5 hole, but because we already have it in the program, I don't want to add another tool just for something simple like this. So it just means you have to go a little bit smaller on the feed, a little bit less on the feed, because if you were going 1,000, let's say, your movements are just going to be rapid and the machine's not going to like that. You'll struggle to size it too. That's our feeds and speeds done. And now in a strategy, so you can see we have an axial depth per cut. So this will do larger pitches between each helical move. So let's have a look at what this does. Just change this for passes for now, just so I can explain this. So let's say we do 1 mil. Okay, so you can see the distance between the first helical here and here will be 1 mil. That's a little bit excessive for a small hole like this. I'm just going to go down to 0.25. Now you can see that helix is a lot less on the angle. The axial step over, so I've got it as passes of 1. So that's just going to do one pass, one helical pass all the way down to the bottom. If you put 10 in here, it's going to break it up into 10 segments with a retract, you see here? So this could be useful if you need to evacuate some sort of swarf from the hole. But for this, we're just going to do one pass. We've already drilled it, so. Radial step over will determine whether, if the hole's, like, let's say the hole's 10 mil and you're using a 4 mil tool, then you're going to have to step out as well. So you'll see if I put this down to something really small, like 0.1. You see how we have multiple step overs now. But for this case, it doesn't matter. We just want one pass. So let's put that at 5, just something bigger than what you'd expect it to be, just so it does one pass for you. The top offset is obviously, we've been through this one before, how high it's going to start above the hole. We know this is already finished, so we can start as little as we possibly need. Like that. And then non-cut moves. So in here you can see we've got start from the center, which always forces the tool to start in the middle and work its way out. And at the very bottom, it should also go back to the middle. This is best practice when you're doing helical holes like this. We don't need to worry about initial engage. Retract is always the same. Not need to worry about this yet, but this will come into play later down the line. And then again, let's just put a nice little transfer smoothing. Okay, and that should be it. Now you can see we've helical milled these holes, and I'll show you the toolpath to see what we get. It's so slow in this window. This is, I can't see what's going on. It must be starting at another hole there. Yeah, you can see there. Flipping out. Okay, that's a bit better. There's helicaling down, coming out. So one big thing that we need to know here is, you see how we're going to the bottom of the hole but no further? We have a 1 mil rad on this tool, so we actually need to go a little bit past the bottom, don't we? Otherwise we're going to have a pip. We're going to be leaving stock in the bottom of that hole. So we go back into strategy, and you can see we have a top offset of 0.5. Let's see what happens if we put a bottom offset in. Now you can see we're breaking through the bottom. And if we drop the tool in there, we can see we've gone past this rad, which is nice. Okay. Now we can delete this one out, because we now don't need to ream these holes. We're going to use the M mil. And now we should just be able to go and regenerate this deburring, because all these features are the same here. Yep. Nice. And that there is this part complete, just like that. And that was not that long at all, was it? That was maybe 10 minutes. And you can see, you know, I've been explaining along the way, you can really see how quick NXCAM can do similar parts like that. So now we are just going to verify the program just to make sure. I'm going to put the stock on so we can see what's happening. All looks good so far. You can normally tell pretty quick if something's wrong, because you'll see the part like gouging through. Like here now I can see it's like faceted, so that I know that's like spot on. That's like a size for size. But you'll normally see pretty quickly if there's things wrong. Okay. So let's analyze this IPW. I'm just going to turn off my block there. Let's analyze this and see how it looks. So again, I'm going to change the number of ranges to, let's say, 3. And I'll do my own colors. Let's say top limit would be 0.25. Okay, so anything this coloured blue is obviously finished. Oh, look at this. So we got a little bit of, it looks like we got a little bit of stuck off here around these corners, which is interesting. So that's obviously going lighter, which means we're moving into the negative stock. So we've actually got a bit of an issue on these corners, which is nice. Means we can actually look into that problem now. And you can see here we've got a bit of a darker colour, and that's because where we're digging in, we're taking stock off here. And that's because of the engraving. And then here you can see it's all nice and blue, all the way down the bore, and then here it sort of tapers off where the rad was of the tool. So that looks mostly good. Let's just have a look into this little issue that we've got here on these corners. You can kind of see it in here as well. You can see this line's appeared of where it's took the corners off. It's this toolpath here. It's because it's rolling around. You can see on the corners it's actually really nice, and as it gets around here it's taking them corners off. It's just rolling around, so you should be able to control that. Have a look in strategy. So here we have convex corners and it's set to roll around. Let's have a look what we get with extend. Now you can see it goes all the way out and goes across. So this has stopped that rolling effect. See how we got the rolling effect here? We are digging in, taking that corner away. Just using an extend. It does sharpen the corner here, which obviously I like to try and keep things smooth, but I guess you can't really avoid it here. Unless we try extend and trim. No, similar. We add smoothing? Not sure that's going to help now. Yeah, okay, so we'll use the extend function, and that's going to stop that. So let's try that again. We need to create our stock for op 2. Now I can just suppress the animation because we've seen it once before. Okay. This looks better. Let's verify it again just to make sure. Analyze it, sorry, not verify it. So now I can see this corner's all fine. And they're all good. Nice. So let's go ahead and create our stock for op 2. Create the IPW so it saves the state on our screen. And then in here, you'll see I've got the non-timestamp geometry of the IPW there. Op 10 resulting stock, and I just need to create that as a part now. So to create a part, we need to go into modeling, assemblies, new component. This component name will be part 2 op 10 resulting stock. Okay, and that's going to be saved under reference model set, which is fine. And then I always do from absolute for the origin of the component. Not too important, but I've covered that in the last video. I'm going to select the part which I want to save, is that one, and I want to delete the original facet body. Okay. Now you can see it's deleted the original, and now we have this. So it's done the same thing as it did before, where it saves it as model 1. Save this part. So, okay. So now when I've hit save, it's asking me what name do I want to save it under. So now I'll specify it again as part 2 op 10 resulting. It's going to the same folder. Okay. Now that's going to save that part away. Oh, I've saved it as par. But we'll look past that. Okay, so now we can go ahead and kick off our second op. So let's go ahead and let's go and open the op1 again, the part 1 op20 file. So we'll open part 1 op20. Okay, and we want to go through the same process now. Now we need to go ahead and we need to change the part out to be our new one. So we want part 2 now, this one. Okay, now that's replaced, and I want to replace the stock as well. So we no longer want this one, and we want to replace the component with my part 2 resulting stock with the name spelt wrong. Try not to spell it wrong like I did. Okay. So now if I highlight this on, now we'll see. That's good. And the great thing about doing it this way is it'll take it all through to your cam session 2. So we're going to change that to part 2, op 10. In the geometry, let's just double check it's got everything. So it's got the correct workpiece. Yep. We have the correct blank, so we need to reselect that because you always have to reselect the blank. For some reason it doesn't like inherit it with it being a new part. So let's just reselect that. So we have to change the filter to facet body like so. And then most of the time when I'm doing stuff like this, I'll just, like, if I was actually doing this part in production, I would just go ahead and I'll just generate all of this top level. I'll just okay it and then I'll start looking through it properly. So I just want to hide that off the screen for now. Okay, so looking at this, it's okay, that's fine. We took off the edge like we did last time. Nothing would have changed. That won't have changed. This is fine. Yep. Planar mill around the outside. So again, this is one that we're going to have to change because we changed the chamfer size. So let's drop that to 1.5 like we did on the last one. Yep. And then the face mill across the top, that's all good. You can see it's bringing on the stock again for me. That is because we have it selected on this in here. I don't like that. So now when I highlight it, it's gone. But if you want to change that like forever, then go into your customer default. So customer defaults and then manufacturing. And then you want to be user interface, operation navigator, and then display selected objects. If we turn that off here, in your customer defaults, it saves the settings forever. Whereas if you just change it locally in the session, every time you restart NX, it's going to load again. Or it'll just be for that part file, sorry. Oh yeah, in the customer defaults, that's how you change things for forever. Like whenever you open the PC fresh or different files, for example. So that is complete. Let's just verify to make sure we're happy. The edge is being taken off, and then we're just stepping down and taking that top. Very nice indeed. Now we can analyze that. We'll say 0, yeah, we'll say maybe 5 layers. And the top one will be 0.5 mil, let's say. Okay, so anything this nice blue color, we know if it's finished absolutely spot on. So that looks very good to me indeed. Yes, I'm happy with that. Okay, so that was a quick video on how we can do the second part. We've done it I wanted you to do it all on your own because it's good for you to just get into that repetitive motion, because we can go through stuff on here, but if you're not actually putting it into practice, it's you'll end up just forgetting it. So it is good that if you did if you use replace component, like, congratulations, but if you didn't, then it's not a waste. It's good that you went through them steps and did it yourself as well. Okay, on the next video, I've got an interesting one. So obviously I release these videos week by week. So I'm thinking on the next one we'll do a challenge. So I'm going to create a part. I'm not programming the part. I'm just going to create a part. I'm going to give it to you guys, and I want you to come up with a way. It's going to be pretty simple, but I want you to do from start to finish with your own tools, your own ideas, your own methodologies. And once you complete that part, I want you to email it to me. And I'll look through it and make sure I'm happy with anything. And I'll email you back and give you any tips or examples or any different ways of doing it. And what I might also do is I might do like a YouTube stream, like a live stream, and I'll review the parts like as it comes. And yeah, that could be quite a fun way to engage with you guys too. Okay, if you enjoyed this one, hit the like and subscribe button, because it really does help the channel. And yeah, we're closing in on 200 now, so we've gone past 100 mark subscribers. So massive thank you to all you guys out there. And also, it's good to see people comment on the videos as well, and definitely trying to involve a lot of that in the video. Like someone mentioned about the verify on the last one, and so I'm trying to show how we analyze the IPWs and go over that sort of stuff. So anything else that you want to go over, feel free to put in the comments below. Thank you.